Hey, what's going on, guys? In this video we are going to talk about properties of logarithm. Let's go ahead and draw the graph for the logarithm first. Now this is the basic graph for the logarithm, and the condition is the base has to be equal or greater than 0. Usually it's greater than 1. Now let's go ahead and draw the graph first. So what happens is it goes through this y-axis but it never touches it, and also it grows exponentially and it stops after a certain point, okay? And also it passed through this point. This is 1 0, x is 1, y is 0, and this is the basic logarithmic graph. And then the condition is, this is the general pattern for logarithm. Log and the base has to be here, and the base has to be usually greater than 1, okay? So this is the base, that should be greater than 1, okay? Now let's look at the pattern of equation of logarithm. Logarithm can be written as like this: base a and x, that's equal to y, okay? Now we are going to see equivalent exponential for this one. For this one we can write an equivalent exponential like a power y is equal to x. So this is one of the things you should remember in order to deal with logarithmic problems. Now let's go ahead and try some problems. Let's say we are asked to find log 10, base is 10 and 1000, and this is equal to x, and they are asking us to find out x. Now if you compare with this one, if we have a power x is equal to y, we can write this one as a power y is equal to x, right? This is equivalent exponential. So what is a? A is 10. What is y for this one? Y is x, right? So we can write 10 power x is equal to, this x is here, so this one is 1000. 10 power x is 1000, and we know that 10 power 3 is 1000. 10 power x is equal to 10 power 3. Since the base are equal, we can equate the exponential, powers, so we can say x is equal to 3. So this is equal to 3, and that's how we deal with this problem. Now let's look at another problem. Let's say we have a problem that's asked us to find out log base 5 and 1 over 25, and that is equal to x. Here they are asking us to find out x. Same way, base is 10, so we take the 5. Here is 5, so we take the 5, and whatever the thing that comes after the equal sign, we put it as power, 5 power x, and that is equal to whatever the number here. So that's 1 over 25, that should be here. Now we know that if we want to write 25 in terms of 5, we can write it as 1 over 5 square, right? If you bring this to the numerator, that's going to be 5 power minus 2. So 5 power x is equal to 5 power minus 2. From this one we can say x is equal to minus 2. And that's how we deal with this kind of problem. Now let's look at the general rules of logarithms. Now let's get rid of this part. Now let's look at the general rules of logarithm. There are 3 rules. Let's take a look at it by one, okay? Rules. Now first let's look at the multiplication rule. So when we have a logarithm base a and we have multiply of 2 variables x times y, we can write this one as addition, like log base a x plus log base a y, okay? The same thing goes to division, like when we have log a and division of 2 variables x over y, this is same as this one, but if it's division, it's subtraction. So we have to put log base a x minus log a y, okay? Now let's look at what will happen if we have a power log a, and if we have x power n, we can move this power to the front. That's the third rule. So n log a base x, okay? This is the same, the base a x, and this is like I just moved this n to the front, okay? These are the 3 things we have to remember when we deal with logarithmic rules, okay? Let's look at an example. Let's say we have a question, something like this. This question is asking expand log base 2, and we have something like x3y z square. So what do you notice first? Here we have a division, right? So when we have division, we can use this rule. When we have a division, that's subtraction. So we can write this one as log base 2 x cube y minus log base 2 z square. Okay. And also, if you notice this one, here we have a multiplication. When we have multiplication, we can use this first rule, this one. So we can write this one as addition, right? Log 2 x cube plus log 2 y minus log 2 z square. And also we have another rule. When we have a power, we can move the power to the front. So here we have a power, we can move this power to the front, right? So 3 log 2 base 2x plus log 2y minus this. So here also we have a power, we can move the power to the front. So this is going to be 2 log 2z. And that's how we expand this one, right? And the question may also ask simplify, like expand, simplify. So you have to go backward like this. Okay. Now let's look at the notation of logarithm. So when we have something like this, log base x, we can write this one as ln of x. You can call it natural logarithm, ln or ln. There are many different ways to call this one. All of them are same, right? So if we have log e base x, that's ln of x. And if we have log x, we can call this one as log base 10 x. So whenever we have base 10, it can be hidden like this. Let's look at the cancellation laws. Okay, this is notation. Let me write the cancellation laws. Cancellation laws. So there are two cancellation laws. For first one, if we have log a and a power x, something like this a and like this log, the whole thing will cancel and that will result in x. Okay, this is for all numbers. This will work with all numbers, for all numbers. And also we have another cancellation law, like for example, if we have log base a x and if we power this one with a, this is similar to this one. This is also equal to x, but this only work with when x is greater than 0. Okay, and this is the cancellation laws you have to know. And I'm going to talk more about properties of logarithm. You can watch it in my next video. I hope this helps. Thanks for watching. Don't forget to subscribe.